Hello everyone, welcome back to the Java tutorial series. In this video, we are going to learn about Java generics. Generics help us write reusable, type-safe, and cleaner code. So by the end of this video, you will understand why generics are important, how to create generic classes and methods, and how they improve code quality. So, what are generics? So before generics, Java collections, okay, it can be array list, set. So Java collections stored objects as object. Okay, what does it mean? So let's say I have one Java collection called array list. Okay, and I have defined like this. Okay, array list. Okay, so in this line I have not used generics, right? So before generics, Java collections stored objects as object. So it is of which type? It is of object type. So whatever object we will insert in this list, let's say list dot add. Okay, here I can add anything. Okay, it can be string, it can be integer. Okay, so it is not a specific type. That's why we are calling it as object type. So array list is storing objects of object type. These are the objects. Okay, and this is object type. So Java collections stored objects as object. Okay, but let's say I have stored Java. Okay, and one more value I am inserting, that is of, let's say, integer. Okay, so these two value I have inserted. So first value will go at index 0 and second value will go at index 1. Okay, now suppose I want to try to fetch the first element. How I will fetch? Using get method. Okay, these are built-in methods. Get index 0. So what value I will get? I will get Java. At index 0, what is the value? Java. That is of which type? String. So if I try like this, okay, this will give string object. So I will store in the x variable of string data type, but it will not work. Why it will not work? Because whatever object we are storing in the list, it is of object type. It is of object type. So whatever value will get, okay, list.get 0 will get Java, but that will be not of a string, that will be of object type. So we need to cast it explicitly in which data type? String. Okay, so first point is Java collections stored objects as object, and the second point, developers had to cast them back to their original type, which was string in this example. Okay, so we have seen here Java was original string and we converted after fetching object type into string, which was the original type of this object. So this casting we are doing explicitly. Okay, so we are doing casting explicitly, which can be like it can create some errors if we are like it can cause some errors if we did not handle properly. Okay, so generics solves this problem. How it will solve the problem? By allowing us to specify the data type in advance. What do I mean by advance? So while declaring this array list, here only we will define the class name, which data type it is of. This array list will hold which data type. Instead of object type, we will specify the type. Let's say I would say string. Okay, array list of string. Now this array list will hold the object of string type only. And if you try to insert some other data type instead of string, then during compile time only it will throw the error. Okay, so instead of object type, it will be storing. We are telling that during compile time only it will find out, and this list will hold only string values. And second point, we don't need to cast like this explicitly if we are using generics. How we are using generics? Using angular bracket. If you are using angular bracket in the declaration, that means we are using generics and we are telling that, okay, this is the data type this array list will contain, like that. Okay, so generic solves this problem by allowing us to specify the data type in advance. Okay, so this will make our code safer and easier to maintain. Why I'm saying easier? Because we don't need to cast like this explicitly if we are using generics. Okay, so basic pointers are there. Like, it was introduced in Java 5. It allows classes, interfaces, and methods to work with different data types. Okay, so here in generics we can provide any classes which we want. Okay, any class, or you can say data type. So that's why they have mentioned different data types. Okay, and the most important, it provide compile time type safety. So if you are providing this angular bracket, we are telling that this data type should be there in this array list. So what compiler will do? Compiler will check this thing during compile time only. So we are checking the type. That's why it is mentioned like type safety. Okay, so we are mentioning the type. This array list can contain only the type string. So whatever value we will add in this list, that should be of type string. That's why type safety. And it will be checked during compile time. We don't need to wait for runtime, and in runtime we will get error, then we will solve those problems. It will not happen if you are using generics. So if we are using generics, we are providing which type it should be, then type safety will be provided during compile time only. So that is a bigger advantage of using Java generics. And it reduces typecasting. As I showed you in this example, without generics, we need to use casting. So we will get object and then we will cast this object type to string or whatever. So this thing we don't need to do if we are using generics. Why we don't need to cast explicitly? Because we are providing in angular bracket what should be the data type the object will hold of in the array list. So while inserting only, during addition only, these things will be checked. So we don't need to cast explicitly. Okay, we will see in example, we'll get more clarity. Okay, so next question is, why do we need generics? Why we are learning generics? Okay, so let's say, imagine you create a list that should only store integer. Okay, so you imagine like one list is there and in which you want to store only integer value. Okay, new array list. Okay, so without generics, in this list we can add. So what is our goal? Our goal is to store only integers. Okay, only integers. How will you validate this thing? Okay, this list should contain only integers without generics, because in this list someone can add a string also, right? And this could cause error, and we will find this error during runtime. Okay, so these things can happen if we don't use generics. How we will solve with the generics? So we will provide the angular bracket in the here itself, and we will say that, okay, this array list this list should contain the objects or values of type integer only. That's why we say type safety. So we are providing here, okay? So during compile time only, these things will be checked. Okay, that's why they are saying so. Type safety we have seen, we are providing which type this list should contain. So type safety will be provided. Compile time error detection. So whatever we are saying that this type should be there in the list, so these things will be checked during compile time error. So let's say if I'm adding anything list dot, let's say add, and I'm providing some values here, right? Values. If those values are not of integer type, then during compile time only it will throw error in this line. That is what compile time error detection. Okay. No explicit casting. Since we are checking during compile time while adding only that values should be of provided data type. Provided data type means what we have declared. Here we have declared integer type. So value should be of integer type only. These things we are checking here. So if we are checking earlier only, in early stage only, that the type should be integer type, we do not need to cast explicitly. So after assigning, let's say integer, I am assigning 100, then list at the index 0 will be 100. If I am trying to fetch list dot get 0, I will get 100 value, and I can easily store in the integer variable like that, like this. I don't need to cast it again to the integer. Why? Because while insertion only, we are making sure the data type should be a provided data type, that is integer. So whatever we are providing in Angular bracket, the data type will be checked during compile time and during addition only. So we don't need to cast here explicitly, since we are getting an integer object only. Okay, so no explicit casting is required. Reusable code and better readability if we are using generics. Okay, so let's go to IntelliJ and have some examples in order to have better clarity whatever we are learning. Okay, so let's go to IntelliJ. What we are learning today? We are learning generics. Okay, generics. But we are learning generics, but we will see example without generics first, so that we can understand the problem, and then how generics is solving that problem we will analyze. So let's say we have array list. Okay, array list, and list equals to new array list. So array list I have defined, and in this list I am trying to add okay, so in this line I have added Java as a string. So at index 0 Java will be there, that is of string type, string data type. Now I am adding, let's say 100. Okay, this is of what? Integer type. Okay, now let's say string name. This is simple variable. I am trying to fetch the first value of the list, list.get 0. Why 0? Because for index 0 will be having first element. Okay, so here I am trying to fetch first element at index 0, but this is without generics, right? This is normal list. It can contain any values. It can be string, it can be integer. Okay, so it can contain any values. Now since it can contain any values, so the data type of the array list is object type. Is what? Object type. That means if I try to fetch using get method, so we will get object type, not string type, integer type, because it can have, this list can have different data type values. So we will get object type. So we need to cast explicitly here to string, then only we will get name. Now if I print, then I will get the value as Java. Let's verify it. So in the output we can see, right, it is Java. That means if we are using without generics and list, so list can contain objects. It is not a specific type. Okay, so we can add any data type values inside this list. And suppose if we want to get this Java, some variable, then we need to cast explicitly. Why? Because this list contains object data type. So we need to convert from object data type to the associated data type. For Java, it will be string. For number, it will be integer. Okay. So two problems we can see without generics. What it is? We need to cast explicitly if we are fetching element from the list. Cast explicitly. And second point, array list is holding of object data type. Object type. Okay, object type. So these are the two problems. So how this is overcome? Okay, we'll give you a brief. So here the array list stores different type of objects. This is what string type. This is what integer type. Okay, because it does not know what type it should contain. Okay, and we also need explicit casting while retrieving values from the list. Okay, which makes the code less safe and less readable. Okay, so how we will overcome this problem? So we will overcome this problem using generics. Okay, now I am using generics with generics. The same example I am converting into generics. How we will convert? So in the declaration itself, we will provide using angular brackets the data type which this array list should contain. If we are specifying any data type, so this list will contain values of that data type only. Let's say if I am taking string as the data type for generics, then it can contain values of string only. If you are trying to insert any other data type values in this list, it will throw compilation error. Okay, so here we have added Java. Since Java is of string type, it is not throwing any error. Here you can see it is 100. It is of which data type? It is of integer data type. But in generics, we have provided it should be string. That's it. That means list should contain only string values. But here we have provided integer. So during compile time only, it is checking the type. That what data type should the list contains. During compile time only, type safety is provided. That is what we are learning generics. Type safety will be provided during compile time. So it is saying that you cannot add any other data type values in this list apart from string values. So we need to provide string values. It can be anything. Okay. Now see, now it is not showing error. Why? Because it is converted to string. We are providing string. Okay. Now here if you say it is showing gray, that means we don't need to cast explicitly. Why we don't need to cast explicitly? In generics, don't need to cast explicitly because now this list knows that this list will contain only string data type, and while adding only it is checking whether the added value is of string type or not. So during adding only the type checking, type safety is provided. So we don't need to cast explicitly because if we are using list.get any index, that will be definitely return the type string. So string can be stored in the variable name of string type. Okay. In previous example, we have not provided here generics. So array list can contain any number of data types. So for that particular data type, we need to cast explicitly. But here the problem is resolved because we have provided which data type this array list will contain. So two problem is resolved. One is type safety during compile time, and another one is we don't need to cast explicitly if we are using generics. So this is the advantage of using generics. Okay. Now, so there are different generic type parameters. Okay, generic type parameters are placeholders for actual data type. Okay, it can be T for type. Let's say I'm showing you just for understanding. Okay, so if I'm using like T, okay, so this will be used for type, and if I'm using E, it will be used for element. Likewise, if you're using K, it will be used for key. Okay, and similarly for V, it will be value, and N for number. So the most common is T of type, and collection like array list uses E element. So whenever we see like this within angular bracket T, E or K, so you should understand like T is for type, E is for element, K is for key, if V is V for value, and N for number, like that. Okay. In key and value, so there will be key and value. We will see in map. Okay. So key and value pair will be used in the map. Okay. So these are like generic type parameter. Okay. Now let's define one generic class. How we will define the generic class? Let's say class name is box. Okay. Box. Now how we will provide generics using angular brackets. Okay. And this is the type. Okay, why we are specifying type? That means it can be any type. Okay, we are providing generic class. I will write here. What do we mean by generic class? So we are defining one class which can be used for multiple data types at a time, only one data type. Okay, I will show you in examples. But first, let's create one class of type T. Why I am mentioning type T? Because during object creation, we can provide any data type. So it is like parameter. You can think like T is like type generic parameter. Okay. Now, let's say I have, what classes have properties and behavior. So let's say property means here variable. Okay. Value of type T. In place of data type, I am mentioning T. Okay. And methods, let's say I am writing T value, and this dot value equals to value. Okay, I am writing just a setter method. Okay, and one get method. So get method means return type will be T. Okay, and get, that's it. I'm writing as simple as I can so that we can understand. And in the getter method we will return value. So this is a generic class. Instead of working with one specific data type, it works with any type represented by T. Okay, when creating an object, we will specify the actual type. What does it mean? So for your understanding, I am saying I can define like this. Okay, integer. In place of T, I will replace integer. Okay, now you can understand. I have provided one data type for this class. Okay, that means this class can use only integer data type for the values, whatever we provide. So everywhere we have used integer data type, see, because we are using in generics integer. But we don't want to limit this class up to one data type only, that is integer. So instead of what, we are using t, so that during object creation of this class, this t will be acting as a parameter. So during object creation, if you are passing integer, then it will take as an integer. If you are passing as integer, this will take as a string. It is a dynamic in nature. Okay, so the type of generics is a parameter which we will provide while creating an object. Okay, so let us create and see how it looks. So let's say I create an object of box class which we have defined just now, and I'm passing here as a string, and box is a reference variable and new box object. Okay, so I created an object of the box class. So while creating object only, we need to pass this generic parameter. So in this class we have written, right, box angular bracket t. That means the value of t is string. So during object creation, we are providing the generic parameter, that which type of object we are creating. Box, but generic type is string. Now we can use only string data type for box class. Let's say box dot set. I'm using setter method, so I can use only string value. Okay, let's say Java. So it is acceptable, and I can print what, box dot get. Since I have set, it will be setting, and I can fetch. Let's verify it. I will comment the above code. So let's verify it. See, in the output we can see, right, Java. If I provide any other value, if I try to provide another other value that other than string, let's say 100, see, it is throwing an compilation error. Why? Because we have specified the generic parameter as string type, so we cannot pass any other data type value apart from string. So that is an advantage. During compile time only, the type safety is being taken care. Okay, so that is the usage of generics. So here t becomes strings, so the box class now stores only string values. The same class can later be reused for, it can be integer, it can be double, or any custom class also. Okay, so this is the advantage of using generics. And so generics are not limited to class only. We have seen the example of class. Now we will see the example of generic method. So let's say I am defining one method, and the return type of that method is of type t. Oh, not type t, return type is void, and method name is print, but the data type I am keeping as dynamic. Okay, and I am doing nothing. I will just print the whatever value we are getting from the parameter. Okay, so we define methods, generic methods, like this. Okay, public static, and the type we need to provide, then return type, and then method name followed by parameter and the data type. So T is the type of the parameter, generic type of the parameter. Okay, how we will call this method? So I will call here only in the first line. So how we will call this method? Using print. In this case, let's say I pass it hello. So it will print value hello. I will comment the remaining lines. Okay. So it should print hello, right? Yeah. Why it is printing hello? We are passing parameter as hello. So value is hello and the type is a string type. Okay. So it is taking as a string. We can pass other data type also. Let's say print 100. Now this time it will take integer because T is generic type. So this time T will be integer and it will print 100. See 100. So if you notice that the same method works for string as well as integer. Okay, without writing multiple overloaded methods. Earlier, how we used to achieve this thing? Using method overloading. We will write the same method name and different parameters, parameter types. Okay. So this is the example of generic methods. So now there are bounded generics. Okay, bounded generics. Bounded generics. There are upper bound, lower bound. This thing I will cover later because we will focus on the topic collections for now. In collection, we will be using generics. That's why I am explaining the concept generics. In the later videos, I will cover in detail regarding this topic. Okay, but I am giving you a brief so that you can have an idea. Bounded generics. Bounded means what? So sometimes we don't want every type, every data type. Okay. So T extends number. Okay. So we want only specific type. That means bounded generics restrict the allowed data types. Here only number and its subclasses like integer, double, float and long are allowed. Okay. So this is called bounded generics. Okay. So here we have provided T, right? So there is another concept called wildcards. Wildcards. Okay. What do you mean by wildcard? Whenever you use question mark, okay, that means wildcard. It can be question mark extends T. Okay. Or it can be question mark extends. Okay, I will comment this. So these are like wildcards. Okay. Question mark super. So this is like upper bound, lower bound. So wildcards make generics more flexible. How it makes more flexible? The question mark represents unknown type. Question mark represents an unknown type. And Java provides three kinds of wildcards depending on how restrictive we want to be. Okay. So this is an example of upper bound. Question mark extends. So whenever we use keyword extends, it is upper bound. Upper bound wildcard. Why we are saying upper bound wildcard? Because let's say we have one list. Okay. Let's say we have one list question mark and extends number. Okay. So this is, let's say, one example. This is what upper bound, right? So this list can reference integer, double, float, or any subclass of number class. Okay, it's mainly useful when we only need to read values. So this is like upper bound wildcard. Upper bound wildcard. Now let's see lower bound wildcards. Okay. So what is lower bound? Let's say for this also we will take one example, list question mark super integer. Okay, what is the meaning of this super integer? So the wildcard accepts integer. In this case, wildcard accepts integer or any of its parent class such as number or object. It is commonly used when adding integer values into a collection. So you can think like upper bound means number or its child classes are allowed. Number or its child class are allowed for this list as a data type. And in lower bound, integer or its parent classes will be allowed to act as a data type for this list. So we are making flexible generics. See, in the above example, we were providing, see here, in array list we are providing hard coding that only string can be passed as part of this array list. So we are restricting the generics. Okay, only one data type is allowed like that. But we are making it flexible. How? Using wildcard. So what wildcard says? Wildcard says, okay, list of angular bracket number. Okay, number will be there. And apart from number, something else will be there. What is that something else? If you are using extends, question mark extends, that means we can use generics as a number class, list of number, as well as the all subclasses, all child classes of this class, that is number. That is, so what are the child classes? Integer, double, float. So in this list, we can provide the values of data type number and its child classes. So this list can have values of number data type, integer data type, double data type, float data type, or any subclass of this number class. So we have flexibility in generics. So this is like upper bound. And what do we mean by lower bound? That means this list can have integer type and something else. What that something else? So it will include integer as well as all parent class of integer. If you are using super keyword, means all parent class of integer class. It can be number, it can be object. Okay, object class, number class, object class. So whatever class that is parent class of this class can be act as a data type for this list. So we are giving some flexibility while by using wildcard in generics. Okay, so we have seen wildcards. Okay, why do we use wildcards? So here, why do we use types question mark extend? This is upper bound. This is lower bound. What do we mean by upper bound? T or its T and its child classes are allowed to act as a data type for this generics, and in this case T and its parent classes. So this is wildcard. We have covered this part. What are the advantages of using wildcards? Okay, so these are the major advantages. It will provide type safety. Type safety means it will check the data types, whether we have provided in the generics that data type is matching whenever we try to add, or whatever operation we are performing, it will check the data type that this data type is matching with the generics or not. Type safety. And this type safety will be happening during compile time, that is compile time checking. Okay, reusable code, no casting is required. Why? Because while adding or deleting whatever operation we are performing, at that time only we are checking. So we don't need to recast it, because we are checking means the type will be same only. So no need to cast explicitly. It will increase better readability and fewer runtime errors. Why? Because during compile time only we are checking the data type, so there is less chance of getting runtime errors. So these are the advantages of using generics. So they make program safer, cleaner, reusable, and easier to maintain while reducing runtime errors. So apart from the advantages, generics also have some limitations. What are those limitations? So they work only with wrapper classes, not primitive types. Okay. So now you might be thinking, what is the wrapper class? So you can think like, I will cover it later, but I will give you a brief so that you will have an idea. Okay. So let's say we have data type int. Okay. So this is like primitive. Why primitive? Because this does not have any built-in methods provided by Java. Only we can store some value inside it. That's it. But in wrapper class, and wrapper class naming convention is also different. It will be starting from capital letter and it will be integer like this. For int primitive type, it is wrapper class is integer. So integer y equal to 10. But wrapper class also provides several built-in methods which we can use. Built-in methods. Okay. So this is an advantage of wrapper class. And there is concept of boxing, auto boxing. Auto boxing means conversion between primitive to wrapper. Okay, this is boxing. Conversion of primitive to wrapper. Auto boxing means automatically these things are happening. Okay. So it provides several built-in methods if we use wrapper class. So that's what it is telling. This is one of the limitations, that in generics we need to use wrapper class. Whatever we provide inside the Angular bracket, we need to have wrapper class, not the primitive type. So if we want to specify that, okay, this list can contain only integer type, then we will provide integer wrapper class, not int. Okay. So keep this in mind. So this is one of the limitation. Okay. So Java removes generic type information during compilation. Okay. Through a process called type eraser, which also leads a few restrictions. Okay. Type eraser. Cannot use primitive types, we have seen, cannot create generic arrays directly, and cannot instantiate type parameter. These are some of the limitations of generics. So these are the real world usages. Okay, so generics are widely used throughout Java, collections, optional, comparable, okay, streams, Spring Data Repository, and popular frameworks. Okay, so array list, hash map. In collection, we will see this generics we will use almost everywhere, I guess. So I will tell you some of the examples while learning these concepts and frameworks. Okay. So let's quickly summarize what we have learned so far. So generics provide type safety. Okay. And it reduces explicitly casting. We have seen with the examples. It improves code reusability. It supports generic classes and methods. We have seen example for both, how we uses generic for classes and methods, and we have seen bounded types and the examples of wildcard, question mark, upper bound, lower bound, upper wildcard and lower wildcards. Wildcards are used for giving flexibility in generics. We have seen with the examples. So that's all for this video. I hope this tutorial helped you understand the concept of generics in Java. And thanks for watching. I will see you in the next video.